There are quite a few videos on my YouTube channel, approximately 1700, and in this video I want to pay more attention, more in a general way, about coil oscillators. So no oscillators with RC components, so resistors and capacitors, but coils. And my focus is especially how to get it working. Well, that's very important with coil oscillators. When you say copy a circuit from the World Wide Web, would be that it doesn't work anyway. This will I hope us give some insight. So what are they, these coils oscillators? Well, let me first draw a line for the positive lead and the negative lead, and I'm only talking now about coil oscillators with NPN transistors because they are so common, etc, etc. So anyway, what are the possibilities with such a coil oscillator? There are a few, say, basic possibilities, and I want to show the first one. Here is that coil. The coil is connected to a transistor. In this case, and in this demo, a NPN transistor. Here we have the base, the emitter and the collector. Here we have the coil. And for such an experiment you can very well use such a coil here with its high voltage side, in this case 230 volts, and here 12 volts, so the low voltage winding and the high voltage winding also with this. But I want to tell, and that's very important, this whole idea also is valuable for high frequency oscillators. So for AF, HF, high frequency, and even VHF, but of course in such a case you must use a typical high frequency transistor. Anyway, why does do many many circuits of that kind not work when you copy them from the World Wide Web? The most important thing is that the bias is not indicated, or the maker of that circuit had success with a certain bias to that transistor. But when you reproduce it, it could be that even when you use the same transistor, the bias is not okay. And that's a reason why you find on my YouTube channel, say, a few hundred videos, not a few hundred, but anyway 100 videos about coil oscillators, and I always focus on the bias. So what's happening here? This must be a transistor for, say, lower frequencies around from 600 Hertz. Let me tell that first, 600 Hertz. And this can even work up to 30 kilohertz. That's a big frequency range. And when we go lower than 600 Hertz, it gets a little bit problematic. That has everything to do with, say, the inductance properties of the coil. But anyway, I gum it now out because I want to show how that circuit must be made. So here we have a coil with a core, or without a coil, sorry, without a core. And now we have the situation that we need a proper bias. That's the, say, the key to success, because this is an NPN transistor. Must have an amplification factor in the order of, say, 75 up to 300. In other cases you can use here a Darlington, and that's made in this way. It is min by the minus, by the way. So here we have the positive, here we have the negative. So this is a Darlington. You can use here, for instance, a BD139, and here a 2N3055, and then especially for the lower frequencies, say between 600 Hz and 18 kilohertz. Well, the most important thing, like I told, is the bias. And the first important idea, and not only an idea, but it is practice. Connect here the potentiometer to the minus. The potmeter must be in the order of 22K up to 25K kilo ohm. And here we always need the protective resistor going to the positive. And now we can align here. And that's extremely important, the bias of the oscillator. This is 1 kilo ohm, given the situation that we have here 12 volt up to 18 volt. So this is the first part of the whole thing. And because we have to do here with a transformer, there is the question of the phase. And that's very important to get such a oscillator, coil oscillator. That's what I'm talking about. Coil oscillator here. Yes, coil oscillators. The phase is very important. So, what's the idea? We couple back a part of the signal that is generated by the transistor when it gets its voltage and current. We couple it back via a capacitor to, say, the base of the transistor here. And we connect the other side here to the minus. So now you have, in principle, a radio, or not a radio oscillator, but you have an oscillator circuit. The frequency is set by of course the natural frequency that such a transformer, in this case this one, or even a high frequency transformer gives. So for a first experiment, use here for instance such a transformer. When it doesn't work, very important to tell, use the Darlington option. So this part here, the Darlington, instead of that 1 NPN transistor. And the most important thing is this, say, use here 100 nanofarad. That often works. The transformer itself, the value of the capacitor, and the bias set the frequency where this works. So, important to tell that we have here on every transformer, like this one, or a serious high HF, high frequency transformer, we have the top and we have the bottom. And also here on the primary side, and in this case it is in the order of, say, 30 ohms, 50 ohms, perhaps 8 ohms. We also have, say, where the coil starts and where the coil ends. So this is the top, and also here the top. And the crux of making this to oscillate is connect the, say, the back coupling line here, this is the back coupling line, to the right electrode of the transformer. So it could be that when you use this, it doesn't oscillate. Very, very simple, because the phase is not okay. So it must be coupled back in a certain phase. So what to do? It's very logical. Of course, what to do is connect that back coupling capacitor here to the other side of the transformer. And connect this one here. Of course, they must not meet, these two wires. That will be a shortcut of the transformer. Connect the other part to the minus. So that is your first, say, experimental thing to do when you want to get such a circuit into oscillation. Use this 1 NPN transistor. Use a Darlington. Can use a Darlington. So I want to indicate here collector, base, emitter, and here also collector, base, emitter. And of course I publish this because, say, I have quite a few new viewers, and when you are, say, a viewer since the time that I started my YouTube channel, say 15 years ago, you will surely know that I have explained this in many cases, but anyway, I think it's necessary. I only have 15 minutes on my camera, so let's put the tag again here to the video, talking about coil oscillators. I have, say, 50 minutes. Let me show another type of oscillator that you can also use. That's very interesting. Of course, this is, say, a certain type of oscillator with a certain name. I don't name it. Could be Colpit, Hartley, or whatever. I'm only interested in whether the circuit works. And here you see, say, in fact, the same oscillator circuit. Now there are 2 Darlingtons used, and I've used this for a high voltage generator to serve an oscilloscope. But the interesting thing here is that we have a transformer with a middle tap. Here is the middle tap, and that makes it much easier to get the whole circuit into oscillation. You don't need, say in a certain way, that back coupling is realized via that middle tap, or the outer tap, or the top tap, or the back, the low tap. Anyway, when you study electronics, you will surely find the correct name for this oscillator. But anyway, this is, say, also a more or less universal oscillator circuit, and you can see that I've used 2 Darlingtons to make it very, very sensitive to oscillate. And also here again, here a typical high voltage coil was used. Anyway, so that was more or less all to tell. The frequency depends also on the voltage. Say on 6 volt it can oscillate and you have a certain frequency. On 12 volt it can oscillate, it also has a certain frequency. Sorry. 18 volts the same. Frequency also depends on the value of the capacitor. Thanks for watching.